Okay, see Lindelof, the triangle sum theorem. Wow. So this is what they give us here, and these are some facts that I guess will help us. That let me see, what did they tell us? They told us that DF and BC are parallel. So DF and BC. So DF and BC are parallel lines. That helps us. And it says that here, let's change the color so we can get a look at this thing. And that AB is parallel to FC, so AB is parallel to FC. And if you're looking at it going, no, it's not, I get why you'd say that, but right, this is NTS, right? NTS, not to scale. Unless they tell you that your drawing is to scale, you can't assume that it is. So that kind of sucks for us, doesn't it? But this thing actually goes out pretty quickly. So let's see how much stuff we can fill in here. So I'm looking at all this crap and I'm trying to figure out what can we get. And let me move this up a little bit. So this is what we're saying. We're saying if we pick this thing up, if we pick this BC line up right here and lay it on top of here, all these angular values become true. So this has to be 60 degrees, doesn't it? Hopefully you see what I'm saying. That if we pick this line up right here, let me see if I can do that. I can. If I pick up this line right here, whoops, sorry. I really want to pick up that line. If I pick up this line here, look, I can move it down. It's this same line. It's the exact same line. So if that's 60 degrees there, if I move it back to where it was, it's 6 degrees there. I hope that's helpful because that's what we're banking on here. Then remember that we are talking about triangle sum theorem. So triangle sum theorem, and triangle sum theorem says that the addition, the sum of all of the interior angles of any triangle have to equal 180. So far we have 60 degrees, that's this one, plus 50 degrees, plus, let's let this be x degrees, plus x degrees must equal 180. Well, we get 110 out of this, don't we? So we get 110. So do a little bit of algebra, subtract 110 from both sides, and x degrees must be 70 degrees. So we have this. This is actually going pretty good. If you know me, you know that I usually do my videos on calculus, but people have been, not bugging me, but have been asking me to attempt some of this stuff, so here I go. So this is 70 degrees, right? And we can use the same thing here. Look, you know darn well that we know this has to be 50 degrees, doesn't it? But look what's going to, here's some proof. One way you could do it is the way we just did it. We could pick up this line. We could pick up this line and say this line is the same as this line down here, right? Because this thing is cut by a parallel transversal. So having said all of that stuff, we know this is going to be 50. But even if we didn't know that, we know that the interior angle, so this angle here, plus this angle here, plus this missing angle, now let this be x degrees here, has to equal 180 degrees. So we have 60 degrees plus 70 degrees plus our new x degrees has to be equal to 180 degrees. Add these two together, what do we get? 130? Is that right, Avery? 130 degrees plus x degrees is equal to 180 degrees. Do a little bit of algebra again, subtract 180 from both sides, and lo and behold, there's our 50 degrees again. So we proved in two different ways that this thing has got to be 50 degrees. Okay, what if we want to know what this angle right here is? Well, what can you say about this? This is kind of fun. All right, well, maybe not fun. It's kind of something, isn't it? We know if we go from here to here, we have angle addition postulate that says that, right, 50 degrees plus some amount of degrees has to equal 180 here, doesn't it? Why is that true? Because we just made a straight line. Here's that line right here. We just created this line right here. So 50 plus what? 130, right? 130. So 100, sorry. Plus, this is 130 degrees. We have vertical angles postulate here that says that this has to be 130 also, doesn't it? Vertical angles. But if you didn't want to do it that way, so then he's like, Charlie, is there another way to prove that? Sure. Why, sure. You could do this. You could say, well, what if we made this angle? What if we tried to create this angle right here, which I think is 180 degrees, isn't it? And you went from here to here. How many degrees? 130 plus what? Well, plus 50 degrees again. So 50 degrees again. Right? And then 50, then look, let's just keep doing this. This is nuts, but hopefully this will really help us to get this thing put away. If we went from here to here, well, how many degrees would that have to be? This would be a total of 180 degrees, wouldn't it? And a total of 180 degrees, this would have to be 130 degrees. So how could you prove this? You could just claim vertical angles, because that's a truth, or you could prove it this way. But look at this. If we add these things together, we had 50 plus 50, we get 100. We had 130 plus 130, we get 260. 260 plus 100 is 360. And there's a circle, isn't it? It's just the coolest thing in the whole world to me. Anything else I really want to do? What if I did this? What if I extended this? Could you get this to 50 degrees here? And this would be 130. I don't know how many. I'm going to leave this. I think I've done enough work for today, don't you? Okay, so I really hope this was helpful for you. If you haven't already subscribed, please subscribe. And if you have questions or comments, let me know them. All right? Thanks.